to our proofs, we're generally trying to prove that triangles are congruent. To prove triangles are congruent, we've so far done SAS and we've done SSS. Now, one of the things that I told you, and I'm going to emphasize again and again and again because it's a key thing about this. When it comes to these proofs, they are all very similar. The pictures, marking things on the pictures are going to help you out, especially if you fill in your postulate sheet and you fill it in appropriately. A number of you I saw had SAS filled in, which you should have yesterday because we did do it in our notes, but they marked things on it that were not the right things. So, make sure you're getting your markings on your pictures on your postulate sheet. They are going to help. Yesterday we did SAS. It told us that AB, if AB was congruent to DE, EF was congruent. Oops, I meant to write BC first. That's okay, it's not the end of the world. To BC. And if you know the third side of each of the triangles, AC is congruent to DF. If you had all three pairs of sides congruent, then you could say the triangles were congruent. Again, note the markings that I put on the picture. I put the tick marks there for a reason. Today we're learning the last two options. So you're going to want to make sure you get the last two filled in on your postulate sheet. I am not going to fill them on the postulate sheet for you. I will put them on the notes though. On page 14 of your notes, if you're not already there, that's where we left off, page 14. We learn our last two options for proving triangles are congruent. And our last two options are angle side angle and angle angle side congruent postulates. Now, people tend to mix up these two postulates a lot because they sound so similar. Angle side angle, ASA, and angle angle side angle, AAS. In their names, it sounds like the only difference about them is that I rearranged the order. And that's on purpose. The difference between these two postulates is, in both situations, I will have two pairs of angles and a pair of sides are congruent. The difference is the location of the side compared to the angles. Angle side angle, the side is between the two congruent pairs. Versus angle angle side, the side is not between the two congruent pairs. So if I have a situation where I know angle A is congruent to angle D, and I'm going to put the angle marks in angle A and angle D, and I also know that angle B is congruent to angle E, I'm going to put the double marked angle in this side. Angle side angle has two pairs of angles and then the side between them. The side between angles A and B is the side AB. The side between angles D and E is the side DE. And so the side congruent in this picture is specifically AB and DE because they're between the two pairs of congruent angles. And if that is true, then our triangles ABC is congruent to triangle DEF. Angle side angle starts very similarly. Angle A is congruent to angle D. Angle B is congruent to angle E. It's still two angles, two pairs of angles congruent, and I'm going to choose in this to show you that it's the same two. The difference being the side length that's congruent is not the one between them. It's not A, B, and D, E. It's either of the other two that it can be. I'm going to make it AC and DF for the sake of our notes. Today's proofs going to look very similar. Make sure you're getting your markings on your pictures. Again, I'm going to say this again. Make sure you're getting your markings on your pictures, because I am still seeing people not put markings on their picture. I can tell from here. Do pay attention to what you write down. If you do not have those markings on your picture, you're going to have a harder time with these proofs. I'm going to pause for a little bit. I'm going to zoom in a little bit because I want to make sure that we've got this all down. When it comes to these proofs, how we approach them is the exact same as we've been approaching them for the last 2 days. Our goal is to get some congruent symbols. Regardless on if we're doing angle, side, angle, 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 side, 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 or side, angle, side, I need 3 things marked as congruent inside my proof to get to that the triangles are congruent. So that's where our goal is to get. Every single one of the proofs is 2 columns in the way that we do them. And we start with our given. All of that stuff is the same stuff that we've been dealing with for the last couple days. We go through our proof and we look for our 5 things. Can't call someone who's not here. Five things are the same 5 things we've looked for since chapter 2. That has not changed. If you need, those 5 things are written on the top of your orange sheet still. Peyton, do you remember the first of the 5 things we look for in a proof? Words. Do I have words in this proof? What word? Bisect. Which postulate sheet holds bisect? Orange. Orange holds bisect. There's 2 different versions of bisect. There's segment bisect and angle bisect. Is this a segment bisector or an angle bisector? Segment or angle depends upon the second thing. The thing that it says bisects this thing. In other words, this. Is that an angle or a segment? It's a segment bisector. And I'm going to emphasize this again with bisect. I'm going to put it way up here. It's always the second thing that gets cut into 2 congruent parts when it says the word bisect. So that's the thing I'm focusing in on. I'm focusing in on AD in this picture. AD's right here. The other thing, in this case the BE that's in the word bisect, that's like the knife. This knife came through, chopped it into two congruent parts. If this is the knife and this is the thing that got cut, what are the two congruent parts? AC and CD. AC is congruent to CD, and that's because of the definition of segment bisector. Wait a second. Isn't there something that I told you to always do in your pictures when you have congruent symbols? Put the little tick marks and the little angle marks on. If you see things that are congruent, put them in your picture. It's going to help us compare the pictures later. Angle A is congruent to angle D. Angle marks, remember, they go inside. And then I have AC is congruent to CD. Calling someone who's not here. Ava, what's the second thing we look for in proofs? Symbols. Do I have symbols? I have congruent symbols, but I like congruent symbols, so I'm not going to do anything with them. Nate, what's the third thing we look for in proofs? Should be on the top of your orange sheet. Should be on the top of your orange sheet.
I never got the right number.
Jackson's trying to help you. Transitive property or substitution. Have we done transitive property or substitution so far, chapter 5? No. We don't tend to do it. All right, what's typically the fourth thing we look for in proofs? Starts with an A. Includes plus signs and minus signs and adding and dividing and multiplying. It was the class that you take as a freshman. Algebra. Have we done algebra so far in the proofs in chapter 5? No. We essentially skip over steps 3 and 4. We go 1, 2, 5. It's great counting, I know. And the fifth thing we look for is pictures. Have you noticed that we use very few things from pictures as well? Do we have 3 separate points on a line? Yes. Do I want to add a bunch of things together in my proof? No. Do we have angles next to one another? Yes. Do I want to add things together in my proof? No. Do I have a linear pair in my picture? Yes, I do. Do I want supplementary things in my proof? No. Do I have vertical angles in my picture? Yes. Do I want things congruent in my proof? Yeah. I want vertical angles. Specifically, I want vertical angles in the triangle, because there is vertical angles here. They're not helpful. They're not part of the triangles. And then there's here. I want this congruent to this, and that's vertical angle theorem that's going to get me that. But for vertical angles, you must use the 3-letter name. Far too often, people are skipping over the 3-letter name. They're just saying angle C is congruent to angle C. No. I will ask you, do you mean this C, that C, that C, that C? I don't know which one's C. Charlie?
Yeah.
What is the 3-letter name for this angle? Angle ACB. ACB because C is the vertex, so it goes in the middle, and the side lengths go towards A and go towards B, hence they are the first and the last letter. Mariana, what's the 3-letter name for this one? ECD. And that was the vertical angle theorem that got it. I write the congruent here, I mark it in the picture. Oh wait, I already did that. Do you notice there's 3 congruencies? That means we're probably getting to that the triangles are congruent. We can say the triangles are congruent provided one of these 4 setups is happening right now. To figure out which setup it is, pay attention. Are they sides or are they angles that you have marked as congruent? Some of them are angles. How many angles are marked as congruent? 2 angles and how many sides? 1 side. 2 angles, 1 side. 2 angles, 1 side is one of these 2. The question is the side between the angles or not? Those 2 angles, is that side between it? Those 2 angles, is that side between it? Yes. Then it's angle, side, angle. ASA has the side between the angles. Triangle CBA is congruent to triangle CED. Okay, you're on page 15 of our notes. Okay. There are a few more examples in this section than some of the previous sections. Heck, yesterday we did 2 examples. The reason there's a couple more in this section is because this section, what am I doing? I should not talking right. Is that what goes there?
No.
No, what goes there? The word given, not the actual things that are given. Don't mind me. Anyway, let's put these in the right spot, and then I'll get back to what I was trying to say. The reason that this section I have a few more examples put in is because I want to make sure that we kind of sum up all the different things that these proofs can do. So that's why I've got some more examples here. First thing I look for in proofs is I look for words. I have the word midpoint. Midpoint's on which sheet? Orange. Have you noticed that 90% of your words are on orange?
Yeah.
If you haven't yet, hey, 90% of your words are on the orange one. Parallel symbols are on the yellow one. And then this one's the new one that just kind of gives us our triangles congruent. It's our one that helps us finish it off. Definition of midpoint says if we have a midpoint, we're going to get 2 congruent segments. The segment itself essentially gets broken into 2 congruent parts. It's always the second one. The second one is the one that gets broken down. When it's bisect, when it's midpoint. It's the thing that comes after the word bisect or the thing that comes after the word midpoint that gets broken down. So in this case, it's the DC. B is the middle of it. Do you see which are its 2 congruent parts? If it gets broken into 2 parts, its 2 parts are DB and BC. Def midpoint. After I look for words, which I took care of here, midpoint was my only word, I look for symbols. I see congruent, I like congruent, but do you also see parallel? The little 2 bars? That's on yellow. Parallel gives me options for angle pairs. I have to find which pair makes the most sense in my picture. To figure that out, I tend to get a highlighter involved. I highlight my parallel lines and then whichever line I'm going to use as a transversal. The transversal, the key thing about which line I want as a transversal is when I draw that line in, that line should cross this parallel line and make an angle inside one of the triangles. And when it crosses the other parallel line, it should make an angle in the other triangle. So, if I try to draw this in, let's say I chose this line to start with. Do these two lines crossing make an angle inside of one of the triangles? That angle. They make that one. When these two cross, does it make an angle in the other triangle? Yes, that one. Which means that's a good transversal to choose. That's the one I want. So I'm going to draw it in on my actual paper now. We're looking at this angle and this angle formed in the triangles. I need to determine what kind of angle pair they are. That's where the yellow sheet comes in handy. Okay, I'm going to line up my parallels. They both kind of go this way. This angle's kind of in the 4 spot. And this one's kind of in the 5 spot. What are you noticing, Jackson? Alternate interior angles. And alternate interior angles are congruent. Alternate interior angle, don't forget the theorem. That was D and C. But can I call them by their single letter names here? Is that a problem? If I say angle D, do I know what angle I'm talking about? Yeah. In the original picture, was there only one angle that was at D? Yeah. Yeah, I extended the parallels to make it look longer, but I drew it in highlighter for a reason, because that's not technically there. I can call this angle D, and I can call it angle C. If you're not positive, you can always do the 3-letter name. There's nothing wrong with calling it angle ADB and angle ECB. It's not wrong. Okay, how many congruents do I have so far? 2. How many do I want? 3. I took care of words, I took care of symbols. Essentially, we skipped steps 3 and 4, and the 5th step is pictures. We still don't want to add things, so those are still probably not going to be used. We still don't want supplementary, so it's probably not going to be that. Do I have vertical angles in this picture? X formed with the sides of the triangle? Absolutely. This angle and this angle are vertical. Angle, DBA, is congruent to angle, CBE. You must use the 3-letter name for vertical angles. Make sure you mark them as congruent in your proof. Speaking of which, I never marked DB as congruent to BC, so I'm going to do that too. How many angles, how many sides are marked as congruent? Angles is 2 of them? 2 pairs? Sides is 1 pair. 2 angles, 1 side? No, that's 2 sides, 1 angle. No, that's 3 sides. 2 angles, 1 side, 2 angles, 1 side. Question is the side between the angles or not? Is that side between those 2 angles? Yes. Is that side between those 2? Yes. So it's angle, side, angle again. Because we did an example before you got here. My bad, sorry. I don't want to go through every single example. I'm trying to figure out which example makes the most sense to talk about. Let's flip over to D, and that'll be our last example. I know. I got yelled at for flipping too soon. Okay, I'm choosing example D because of the fact that example D has similarities but differences from the previous problem. Do you notice that in many ways the picture looks very, very much the same? They're very, very similar pictures, and in fact, a lot of these are going to have similar pictures. But that doesn't mean they're all the same proof. Shoot. We do need to talk about about example E as well. Sorry, we have to do the last two. There's one other thing I needed to show you. I spoke prematurely when said that this would be the last one. This one's a quick one though. Okay. Angle S is congruent to angle U. I see congruent marks. I should make sure to mark them right away this time, unlike last time. RS is congruent to VU. That's segments, so that's tick marks. Go through my 5 things. I don't have words. The only symbol I have is congruent this time. If you do not have parallel, you are not looking at your yellow sheet for alternate interior, alternate exterior, or consecutive or corresponding angles. You could still look at these ones because these ones don't require parallel, but you don't look for parallel here. You don't have parallel to look for the other ones. That's what I meant to say. I skip over steps 3 and 4 on these proofs. I go to step 5. In the picture, have you 99% of the time it's always 2 things. Either there's vertical angles or it's the reflexive property. Are there vertical angles in my triangles here? Do you see an X formed with the side lengths? Yeah, there's vertical angles. Here's my X. The angles across from one another on the X are that one and that one. Angle RTS is congruent to angle VTU by vertical angle theorem. I already used the single marked angle, so I use the double marked angle. I have 3 pairs of congruent so far. How many do I want?
3.
I want 3. I have 3. Sweet. How many sides? How many angles? I see 2 angles and 1 side. If it's 2 angles and 1 side, could it be that one? No, look at the letters. 2 sides, 1 angle. Not what I want. 3 sides, not what I want. 2 angles and a side, 2 angles and a side. Is the side between the angles or not? Here are my 2 angles. Is that side between them? Is this side between these 2 angles? Or is it not? Not sure? Jada? Is this side between those 2 angles? No. No? Haley, do you think this side is between the 2 angles? No? Zion, do you think this side is between those two angles? No. If the side is not between the two angles, is it angle, side, angle, or angle, angle, side? Angle, angle, side. Triangle RST is congruent to triangle VUT. Okay. So, there is just the one last one that I want to talk about, and it's because of the fact that it shows something else that I forgot that we haven't seen enough of, that I'm still seeing mistakes on. But we'll go through it fairly quickly. I highly recommend, if you see a congruent symbol, you mark it in the picture right away. Those pictures tend to kind of help, especially with angle, angle, side, and angle, side, angle. I see the word bisect. Is this an angle or a segment bisector? In other words, is this an angle or a segment? It's an angle, which means that gets cut into two congruent angles. If the second thing is an angle, then it's two angles that are formed when the bisect comes through. So using the definition of angle bisect. Now it's angle LPM that got bisected. You've noticed that I tend to darken them in, and it got bisected by PO. In other words, this is the knife coming through. When I take an angle like this and throw something smack dab through the middle of it, it creates two smaller angles right next to one another. This angle and this angle. In other words, this angle and this angle. That is one of the most common things I'm still seeing people have issues with. Angle MPO and angle LPO here. This angle and this angle. So, I wanted to get that down. Otherwise, we go through our 5 things. We took care of the words. There's only congruent symbols. We skip over steps 3 and 4. The 5th step is looking at the picture. There's generally 2 types of things we get out of pictures. Vertical angles. Any vertical angles there? No? Or the 2 triangles share a side or share an angle. Do the triangles share a side or share an angle? What do they share? A side. What's the name of the side? OP. Which means OP is congruent to OP. And that's reflexive to say something is congruent to itself because it's shared. We have our 3 congruences, so we know that the triangles are congruent now. Technically, you should check that it fits one of the options. I will tell you right now, it fits one of our options for what makes things congruent. Here's my 3 congruences. How many of them are sides? 2 of them. How many of them are angles? 1 of them. 2 sides and an angle. Which is my only option that has 2 sides and 1 angle? Not those 2. Those have 2 angles, 1 side. It's the opposite of what I want. Not that one. It's 3 sides. Side, angle, side. Double check. Is the angle between those two sides? Yes. Is the angle between those two sides on that triangle? Yes, because if not, it doesn't actually work. It does fit, so it's SAS.